3, 2. Welcome everyone to the Boiling Point Podcast. I am your host JD, and this is episode 77, The Facts About Global Warming, Part 1. This will definitely be a multi-part episode as we go through our new guest, and new senior global warming correspondent, Keith Nonemaker. Welcome to the show, Keith.
Thank you.
And, of course, senior faith correspondent, Pastor Gavin, is here as well. And I'm glad he's here because we're going to definitely include some biblical into this. So it's going to be a whole conversation here.
Yep. Wow.
Make sure you please share it out. Hit that like button. Hit that share button. It's going to be the way that we grow, the fastest way that we grow. Marcus Frederiksen, he's the one that played us in. He'll play us out at the end. Go check out his music at reverbnation.com/Marcus Frederiksen. Of course, we have the storefront. Both Pastor Gavin and I are wearing the American Cross Design t-shirts today. So make sure you go and pick up one of them at our storefront, bonfire.com/store/The Boiling Point Podcast, all in lowercase. You can find us on Facebook, Parler, YouTube, and Rumble. So hit a share and like no matter what platform you're watching on. Hit that like button, hit that share button. Okay, so Keith, we're going to be talking about global warming here. Now, you wrote a book, which, Pastor Gavin, would you like to hold that up for everybody?
Yeah.
It's called the Anthropogenic Global Warming Skeptics Guide. This is written by Keith, and we're going to talk about what anthropogenic means in just a moment. But he wrote this book. It's about 98 or so pages, I think.
Beats me. I haven't looked at it in a year.
It's definitely it's near 100 pages. It's
78?
Quite 78. I was way off. 79. It's just when you're reading through it,
80.
It feels like more than that. So 80 pages. It's 80 pages of information on global warming, and we're going to be going over this book over multiple episodes. This is just going to be the first one.
And it's really excellent. I mean, I've read it numerous times, and it's good to have a reference, like if you want to look up something.
Yes.
And my copy, I underline things in it. It's really well written.
I haven't gotten to the underline and highlighting part, but after I've read through it once, I realized that the second time I read through it, I'm going to need a highlighter because there's a lot of really good information in here, and it's all accurate. Keith, let's get your credentials before we actually dive in. Why should we listen to what you have in this book?
Well, the book is a little outdated. Let's start with the title, Anthropogenic Global Warming Skeptics Guide.
Which you wrote in 2011.
Anthropogenic means man-made. People call me and people like me science deniers. I do not deny that there is some warming going on around the globe, at least depending on when you start your temperature scale. We are certainly warmer today than we were in 1816. 1816 was known as the year without a summer. And that year, there was still ice on the ponds in New England and New York in June. It was so cold that year that there was essentially no growing season. And people died of starvation because there was no food to eat. We have warmed up since then, that's true. But is that warming anthropogenic? Anthropogenic means man-made. And I would say there's not sufficient evidence to indicate, and plenty of evidence to indicate, that the warming that we've experienced is not anthropogenic. And I call this my Skeptics Guide. People really fall into one of two categories when it comes to global warming. They are either alarmists. They not only believe that their warming is occurring, but that we have to go into a panic and take drastic measures to stop the warming. Or they fall into the skeptic category, that's where I am, where you doubt one or another aspect of the science.
Which we'll get into in just a second here, but I wanted to ask you.
You want my credentials?
Yeah. I wanted to get them out of the way first, so people know who you are and what you're bringing to the table here.
Okay.
So in college, you studied mathematics.
I was a math major in college. I also have a master's degree, a Master of Divinity degree, and I'm working as a pastor now, along with my wife. I do not have a PhD in climatology. Not very many people do.
Nor do I.
So you can ignore everything I say because I'm not sufficiently credentialed.
Well, you're a mathematics major in college, which gives you at least credentials in the terms of statistics and
lets me
graphs
know
and
enough
information.
math that I can tell when somebody's trying to snow me with phony numbers.
Exactly, because you don't really need to be you don't need a PhD in global warming or in climate or anything like that in order to understand what's happening with the climate of the world, right? You don't need that PhD behind your name to understand it.
Well, that's exactly right. A person of ordinary intelligence can understand enough to see that they're trying to snow you.
Yes, and now why did you decide to write this book? You have at the very beginning that in the summer of 2011, your denomination, the Church of the Brethren, passed a motion at their annual conference that recommended that individual congregations should study the issues related to anthropogenic global warming. But why did you decide to take it outside? Why did you decide to do it yourself then?
Well, it all started when a Facebook friend of mine posted a picture of a very heavy snowfall around his house. And I lightly made a comment about where's the global warming with this 6 feet of snow around your house.
Yeah.
And he came back at me hard and said, you ought to study the science. Global warming is real, and you're a fool to not recognize it. So I took his challenge, and I did start studying and discovered that a lot of things were not as they seemed.
Excellent. Isn't that interesting though how it goes? Just an exchange on Facebook, leads to you studying it and deciding to put together a book because of so much of the misinformation that some people are trying to put out there and push about the narrative regarding it.
And a lot of people have been saying that snow is going to be a thing of the past before long, and they said that 20 years ago.
It's snowing outside my house right this very second at the moment we're filming this, by the way. Just saying.
Right.
Okay, so major in mathematics, so you can understand data, graphs. That's where your expertise comes in, and that's where a lot of this is going to actually take place, because that's what the people who are claiming that global warming is happening, they use these scary-looking graphs and these scary numbers to scare people into saying, oh my goodness, if we don't do something right now, it's all over. We're all going to die. The world's going to be over.
Yeah, another thing, Keith worked for a long time as a computer teacher and then a computer systems analyst.
Correct.
So he's really good at analyzing things.
Yeah.
Especially with the mathematics background. So, that he's well equipped and credentialed to look at statistics and say, are these bogus or are they valid?
Yeah, and that's really where a lot of this argument is going to come down to. The statistics, really, it is. Because it's about past temperatures, current temperatures, and that's, a statistician should be able to look at those numbers regardless of whether they were about climate or baseball and figure out if something's not right.
Yeah. Now, Keith, I wanted to ask you the year without a summer, 1816.
I believe it was 1816.
Yeah, okay. Was that because of a lot of volcanic eruptions that blotted out some of the sunlight we would get? Was that what caused that? I seem to remember, I'm thinking that was the cause, but I'm not certain. I wondered if you knew what caused that.
Well, it's true that major volcanic eruptions will put dust into the air and create kind of a shadow over the whole Earth. Yeah. And that can cause cooling temporarily. Whether or not that was the case with 1860, and I don't recall.
Yeah, I believe I read somewhere that that's what did cause it. So I think that's accurate.
So let's just start with the most basic questions here regarding this and your book. Like I said, multi-parts. This is just going to be the first 27 or 30 pages or so that we're covering of his book here. Is the temperature rising? And let's save it for is it man-made for the second part of the question. But first, let's start with, is the temperature rising?
Well, the temperature rises and falls every 24 hours.
Whether if you weren't aware of that, now you are.
Whether it's rising and or falling in the long term depends on how long of a term you look at.
Okay.
I'll give you some examples. The good data that we have on worldwide temperature depends on the satellites that collect temperature data over most of the Earth.
Which since only has been since 1978. So you're only talking about
Correct.
40 years of
So we
data.
have 4 complete decades of data. 2 of those decades show cooling, 2 of them show warming.
That seems pretty balanced.
Now, to go back further to check earlier temperatures, you have to rely on other kinds of data. Thermometer data. Now, if you had a thermometer every yard or so over the entire face of the Earth, you could use thermometer data to get a global temperature, but you don't. There are relatively few areas that are covered by thermometers, and thermometer data goes back to about 1750. There's one place on Earth in central England where they have thermometer data back to, I think it's 1685 or so, where they have a consistent record of the temperature at that one spot.
Yeah, that's only in England. That's not across the world.
Correct.
Now, you were saying if you had a thermometer every yard or so, that would be an accurate representation of the temperature of the planet. But
Right.
aren't there? There's towns and cities. Is that not enough data? They don't, or did they not report enough on the weather at the time for there to be enough data?
Well, you've got pretty good data for the United States back to about 1895.
Okay.
They had a good many thermometers that went into process when the Weather Service was started, which was around the 1890s. To go back further than that, you have to start looking at proxy data. Now, let me give you an example of what proxy data means. You can cut down a tree and look at the tree rings, and you can measure how thick each ring is. And if all other factors are equal, the tree rings will be thicker on warm years, thinner on cold years. Now, the problem with that is all other factors aren't equal.
Yeah.
There are many things that affect a tree ring.
You're talking about sunlight, soil composition.
Amount of sunlight, the soil, the competition
Rain.
for moisture, the amount of moisture, the amount of rain, and so on and so forth.
And that's the problem with that's what we're going to be getting into here. That's the problem with some of the data that we're going to be going over, is that to conduct a good experiment, you need a number of things to be consistent, and then you
Correct.
keep the variable to test the variable.
You need one variable, and you need to keep everything else consistent, which is pretty much impossible on proxy data.
Yeah, and well, it's really pretty impossible on planet Earth. Even if we have
Correct.
the most sophisticated equipment, you can't keep rainfall the same all year round for certain areas and not for others. So,
But by collecting a good bit of proxy data, and there are some strange proxies. For example, one guy looked at old paintings back to the 8th century or whatever, and examined the cloud formations in old paintings. And certain cloud formations tend to suggest that the weather was either warmer or colder in that time period. So by putting all that proxy data together, you can get a long-term measure of how the temperature flowed in certain areas of the Earth. And they've got enough proxy data now that they can almost get a worldwide temperature scale for a couple of thousand years. And here's what we know. Back in the period from around 1400 to around 1800, the Earth was going through a stage known as the Little Ice Age, when temperatures were much lower than they are today. So if you draw a temperature line starting in, say, 1600 and going to the present, it's going to show that the Earth is warming. But you go back further, back to around the year 1000, in that time period they were going through a warm phase known as the medieval warm period. And if you draw a line from 1000 to the present, there are many ups and downs, but overall the line is going down. We're actually cooler than we were during the medieval warm period.
Okay.
That's 1,000 years ago. You go back 1,000 years before that, the Earth was in the Roman warm period around the time of Christ, and that was even warmer than the medieval warm period. So if you start there and draw the line, we're going down even steeper.
So Keith, what I think I hear you saying is, are we in a warming or a cooling trend? Well, it depends on what you compare it to. If
Right.
you start with a warmer period to us today, well, then it's getting cooler. But if you start your measurement with a colder period to today, well, then it's warmer. So looks like these statistics can be manipulated by people to show one thing or another depending on when you start.
Choose your starting point, and I'll prove that it's warming, or I'll prove that it's cooling.
Yeah.
That's interesting.
So it's kind of relative.
And I want to circle back to something you said about the paintings that people could gather some evidence based on the paintings. How accurate is that? Like, is that really considered something that is real? Like, that's generally considered accepted that paintings back in the day, whether they had clouds or the sun was shining or whatever, that was to what the weather was outside. And not just a choice by the painters, I guess is what I'm trying to say.
It is a piece of evidence. Now, if you've ever served on a jury, you know that one piece of evidence isn't going to prove or disprove the case.
Yeah.
But you take all the evidence together, and you can get a solid case.
Okay, so you take all. Okay, so it's not just you taking one painting from 1 year, but you take all the paintings from a certain year.
From many years.
Yeah, or from many years, and if they all have the similar or the same kind of weather in the background or whatever, then it can generally be considered.
It's a good clue as to what the weather was at that time.
Good. I'm glad we clarified that, because I'm sure that some people were watching going, paintings, really?
Yeah. No, Keith, if I could ask this, which historically has been better for human life on Earth to prosper and to thrive? And which is more deadly? Global cooling or global warming? Which is better for human life?
Okay, if you look at death patterns based on weather, there are many more diseases related to cold weather than there are related to hot weather. So overall, it would appear that from a health standpoint, warmer weather is better weather. You can also look at advances in architecture and science and so on, and those advances seem to come more frequently when the weather is warmer, when the climate is warmer.
You mean like the early medieval period, for example?
During the medieval warm period, that's when all the great cathedrals of Europe were built, for example.
So how about agriculturally? How does the cool weather compare to warm agriculturally?
If it gets warm enough at a certain location, you can have 2 crops in a year instead of just one. So for agriculture, warm weather is much better.
So even though these people are saying about so let's use that to segue into the glaciers here for a minute. Now that's not in the first 30 pages, but let's just talk about it for a moment here. Warmer weather, that's where they're saying, warmer weather, you're saying more work gets done, people are more prosperous, food is more plentiful. But what about the other side of that? The argument is that the Arctic is melting, the glaciers are melting, and that sea levels are going to rise.
Okay, do sea levels rise if the Arctic melts? That's a good question. Now, if you take a glass and fill it, put a couple of ice cubes in and fill it to the rim so that it's not quite but almost overflowing, and then you wait until all the ice melts, it will still be right at the rim but not overflowing. Floating ice occupies exactly the same amount of space when it's ice or when it's liquid.
conduct that experiment if you're watching this, and conduct it right now. Fill up a glass all the way to the tippy top, with some ice cubes inside it already, and then after the ice cubes melt, see if any has leaked up overflowed out the side. It's not going to, because it, as he just said, it takes up the same space. And these Arctics that they're claiming are melting and are going to raise sea levels, they are in fact floating. They're not like down into the... They're floating.
At the North Pole, it's liquid, so the ice is floating on top. Now, if the South Pole were to melt, that's on land there. So that would increase the level of the sea. But the sea level is already increasing. The oceans are getting deeper, and they have been getting deeper for a long time. And I'll tell you how I know that. There are sea level gauges that measure the sea level. Some of them have been active for quite a long time, and the oldest one in the United States is at San Francisco, where they have been measuring sea level since 1840. And what you will see if you look at the entire span of the data from the San Francisco sea level gauge, you will see that the sea has been rising since 1840 at about 3 millimeters a year. That's about the thickness of a matchstick. And during the first 20 years of that gauge, from 1840 to 1860, the sea was rising faster than it has risen in the last 20 years.
Before industrialization.
Yeah. Correct.
Before. Now, what was causing the sea level to rise? Or is it just a normal, natural thing that happens on the planet? Occasionally the sea levels rise a little, they go back down a little.
Well, we know the planet has been warming since the 1840s. And that doesn't put more water in the ocean, but it causes the water that's there to expand a bit. Okay. That's what causes the sea level rise.
Okay. Well, see there, I learned something new, which I always like doing. I like to learn something new at least once an episode.
Yeah, I didn't think of that.
No, I didn't either, actually.
Because we're so used to being brainwashed into thinking, the Arctic's melting and that's raising the sea level.
Yeah.
Oh, by the way, here's a trivia question for your viewers. The United States has a sea level facility to keep track of the sea level. Where do you suppose it's located?
Well, you know what? Let's turn that into a real thing. If you're watching this, if you know the answer, leave a comment on where it is, and we'll give you the answer on Keith's next episode. So we'll see how many people actually know.
I'm gonna guess Hawaii, but I'm not sure.
Don't tell us yet. Wait, save it for the next. Save it for the next episode. I'm not gonna say Hawaii. I'm going to guess. You know what? Let's see. Right in the middle of the. It's not going to be near the water at all, is what I'm saying. So like Oklahoma. My guess is somewhere in the central of the United States and not anywhere near the ocean, because that's what some things about the United States, they don't always think things through.
When was this established? This place where they measure the.
I don't know that.
Oh.
All right. Well, we'll have to save it for next time. If you know the answer, leave it in the comments, and we'll get the actual answer on Keith's next episode.
Okay, so now Keith, how did this global warming climate alarmism thing, how did it start? And who started this movement? How did it begin? And there might not have been any one person, but what really started this movement, and how did it originate?
Well, it originated largely as a political movement, not a scientific movement. And it's difficult to pick out a starting point. I remember the first introduction to climate change that I'm aware of in my own life is when I went to Los Angeles on a vacation, and that would have been about 1966. And back then they were talking about the smog problem. And when I got to LA, I couldn't keep my eyes open because they just burned whenever I opened my eyes. The smog was bad. I then after a number of years, was back in LA living there, and that would have been in 1981 or so. And there was no problem with the air at that point. So they had pretty much solved the smog problem. The idea that the globe was warming probably started around the 1980s. But I've looked at the New York Times reports on climate change over the years, and you'll see that way back they had a warning that the Earth was getting hotter, and then 10 years later a warning that the Earth was getting colder, and then hotter, and then colder, and now we're in a it's getting hotter phase, which is probably why they don't talk about global warming anymore. They talk about climate change. Because if it gets warmer, climate change. If it gets colder, climate change. If it doesn't go anywhere temperature-wise, that's climate change, because that's never happened before, and that's different. That's climate change. Wetter is climate change, drier is climate change, you name it. So they don't have to prove anything. Whatever happens,
It's all climate change.
it's going to be climate change.
Yeah.
Well, Al Gore, though, he was. Let's talk about Al Gore for a minute, because he was somebody who definitely brought it to the mainstream and made it more of an issue than it actually should have ever been, or should be even today.
And then after Al Gore, could you explain the role that the United Nations played in promoting this too?
And did Al Gore really win a Nobel Peace Prize? Is that real? You have that in your book.
Well, if I have it in my book, I'm sure it's real.
Okay.
I think he shared the Peace Prize with maybe the UN agency.
Doesn't that make you wonder about the Nobel Peace Prize, though?
Yeah.
He also won some kind of a film prize for his film,
An
An
Inconvenient
Inconvenient Truth. That's
Yeah.
the one.
So the what's the name of that?
Intergovernmental Panel on Climate Change. Is
Yeah.
that the one?
Yeah.
IPCC.
Yeah, the
Yeah. United
United Nations formed that. Did that come before Al Gore or?
I believe it
around-
did, yeah.
Yeah. So I remember reading in your book that the International Climate Change Panel, or whatever their name is, from the UN, that they are actually not scientists.
Well, it's not called the Scientific Panel on Climate Change. It's
Right.
called the Intergovernmental Panel on Climate Change,
Yeah.
which means that it's all about governments and what the governments believe and what they want.
Right. And so they, now they try to get things that so-called scientists say and put the data and information together, but they're not actually scientists.
Yeah, and that's what I was laughing at.
Yet they're one of the main
his-
promoters of this.
Keith's remark about, well, it's not called the Science Panel on Climate Change.
Yeah. Yeah.
Oh, man.
So now,
It's just it just when you hear things like that, I laugh, because people who believe this, really, I mean, really, there's you're talking about a panel that doesn't even have any scientists, or very few scientists within the organization,
yeah. Now,
and you still believe it.
yeah. Now, Keith, let me ask you this. Okay, so you worked with computers for you've taught computer science, and then you've worked with computers. Could you explain, like, the part that computer models play? What are computer models? What part do they play in these predictions? Like, oh, the Earth's getting warmer, and
And are these the
we're all
same?
in danger.
And are these the same models that weathermen use to try and predict the weather?
Okay,
So, what are computer models, first of all?
I'd like to interrupt before I answer that
Yeah.
question. I'd like to talk about what does cause global warming if it's real.
Okay, sure.
Give you some science background here. Now, if you take a toddler outside on a summer day and ask him, what's causing the warmth? I'll bet you he can give you an answer right away. What would you say is the answer?
The sun.
The sun, exactly. The way that the sun works is it puts out light. Light is a form of energy. And heat can't travel through empty space, but light can. So the light comes down and hits the Earth, and some of it converts to a different form of energy, heat energy. A lot of it just bounces back out into space. And as long as there's just enough lingering around to keep the Earth at a constant temperature, we're good temperature-wise. Now, I'll tell you about a real, what do they call it? Greenhouse gas.
Okay.
Water vapor is a greenhouse gas. Water vapor is what forms clouds. And if you stand in an area where the sun is shining bright, but there's a cloud between you and the sun, you'll feel a little cooler. That's because the cloud is reflecting the light back out into space before it ever gets to the surface of the Earth. So the greenhouse gas actually cools the planet. It doesn't warm the planet.
If I can comment on that for just a second, because the whole problem with what they say with greenhouse gases is that it traps in the heat.
Okay, now I'll tell you how that works.
Yeah, because the Earth doesn't heat itself, right? Like, it gets heated from the sun. The Earth, I mean, down deep in the center, the middle of the Earth may have,
hot molten
lava and so forth, but the surface of the planet doesn't heat itself. It doesn't get its heat from the planet, right? It gets from the sun.
The heat is coming from the sun.
Yeah.
Now, to go on, we have to understand something called black body radiation. And to understand that, think about the burner on an electric stove. That burner is almost black in color. When we talk about black body radiation, there's no truly black item on Earth, but that burner is close to being black until you start heating it up with the electricity. Once it gets hot, it starts to glow in a dull red color first, and you heat it up more, and it starts glowing orange. And if you could make it hot enough, it would go beyond orange into yellow, and then white, and finally blue. You heat something very, very hot, and it'll glow blue. Okay, now you turn the heat back down, and it goes backwards. It goes from blue back to white, back to yellow, back to orange, black to the dull red, and then no color at all in the visible range. But even at room temperature, that stove burner is glowing. It's just glowing in the area beyond the red, the infrared area. Now, the same thing is true of your streets and your pavements and your car and anything that's outside. Even if it's at room temperature, it's glowing with heat in the infrared spectrum. Now, what that means is the sunlight that's coming down and hitting us during the day, some of it bounces back, other light heats stuff up, and then at night, that glowing car or sidewalk or whatever is giving off light. It's light that we can't see, but it's infrared light, and that light is going out into space. Now, if there's a cloud in the sky at night, it's trapping that light that would have gone outward from the planet, keeping it in so that it's making the planet warmer. And you can experience this. If you go outside at night, on a night that's clear, you can see all the stars, it's going to feel a little bit chillier than if you go out at night when it's clouded over. The clouds trap the warmth, make you feel a little warmer at night on a cloudy night. So that's how the greenhouse gases trap the heat that's coming off of the Earth that was heated up during the day.
It traps it at night.
Traps it at night.
So we get the Earth gets its warmth from the sun during the day, and then the clouds trap it in at night, which makes sense because when it's clear out, it is cold.
So the heating effect of the greenhouse gas happens at night, trapping the heat in.
Not during the day.
Not during the day.
Now, let me ask you, because I want to... Oh, you got something else? Go ahead.
Let me add one thing.
Mm-hmm.
The culprit in the so-called man-made global warming is carbon dioxide. Now, water vapor in a cloud looks white. That's because it's reflecting all kinds of light. Red, yellow, green, blue. And it's reflecting the infrared light, which heats at night. The color of carbon dioxide is clear, meaning it doesn't reflect any of the visible light spectrum. It does reflect part of the spectrum outside of the visible spectrum, but it's on the wrong side. It's at the it's at the ultraviolet end, not the infrared end. So carbon dioxide is not trapping the heat that would escape at night. So it's not a greenhouse gas at all. Not in the real world.
So water vapor is a greenhouse gas, but carbon dioxide is not.
Correct.
That's interesting.
Ian, Keith, if I could ask, what percentage of all greenhouse gases is comprised of water vapor, roughly?
Well, it depends. That's highly variable because you have humid days and you have dry days. Yeah. But probably,
do you have a ballpark figure?
Yeah. Probably water vapor is 99% of all the greenhouse effect that we get.
Right. So
Water vapor.
That's what I've heard too. Yeah, 90 to 95, somewhere in around. In other words, most of the greenhouse gases are comprised of water vapor.
Yeah, which happens naturally when the sun.
Right. You can't control it.
Yeah,
so
you can't control
CO2 is what percentage of all the greenhouse gases would CO2?
The amount of CO2 in the atmosphere is 400 parts per million, or that would be 0.04% of the air.
So a fraction of 1%. So
yeah, not even 1%.
Most of what makes the greenhouse gas effect is water vapor, but yet CO2 is just a teeny weeny sliver of that. And we're worried about CO2.
Now, even with... since the Industrial Revolution and everything, has the amount of carbon dioxide that we put into the air, has that changed anything? Has the parts per million rose since then, or is it so insignificant that it's been nothing?
Okay, let me talk about the measurement of CO2.
All right.
A while back, there was a scientist who wanted to start doing consistent measuring of the carbon dioxide in the atmosphere. And he said, well, I don't want to put the facility in an industrialized area. I want to put it way far away from people so that it won't be affected by factory smoke and whatnot. So he chose a location on the side of a mountain in Hawaii. Now, if I were setting up a facility that I was going to run, I'd probably want to put it in Hawaii too. That sounds like a good idea to me.
Yeah. But the problem with that... There's a problem with that I imagine you're about to get to, right?
I will get to that, yeah. So they've been measuring carbon dioxide in the atmosphere for, I think, around 60 years now.
And that's the only place.
That's the only place that they do a consistent, continuous measurement. And what they found is that it goes up and down annually, while overall, if you round it off, if you smooth out the curve to take care of the annual fluctuations, it's been going up at a constant or nearly constant rate over the entire lifespan of the facility. Now, if you look at other sources of carbon dioxide information, and there are many of them, there is a catalog that is available of 10,000 carbon dioxide measurements that have been taken since the mid-1800s. And many of them are lower than today, and some of them are higher than today. Some are substantially higher than today's readings. Now, the problem with the facility being located on the side of a volcano in Hawaii, there's really two of them. One is that volcanoes are the most concentrated source of carbon dioxide on Earth. So putting it right next to an active volcano means that your measurements could be thrown off by the smoke coming out of the volcano.
Remember, this is why he chose the volcano, because he didn't want it to be affected by
Right.
factory
smoke.
Or industrialization.
Yeah.
But there's also a conveyor belt in the ocean that takes warm water one direction and cold water the other direction. And carbon dioxide gets into the water as well. This conveyor belt gets up close to the North Pole, loads up on carbon dioxide, because right where the water meets the ice, that's where it will get the most carbon dioxide dissolving into the water. So it's always got a consistent high amount of carbon dioxide up there, comes back under water to the South Pacific, comes up to the surface, and the carbon dioxide is released there. So there's a lot of carbon dioxide coming out of the water in that area of the Pacific as well.
Now, when you say conveyor belt, you don't mean like a legitimate actual conveyor belt.
It's a liquid conveyor belt. Water.
Yeah,
water
but it's a
in
natural. It's a natural thing. It's not something.
Convection system.
Yeah. I just wanted to make sure, because I know there's likely someone watching going, so we built a conveyor belt under the ocean? No, we didn't.
No.
We talked about a natural thing that's happening.
Yeah.
I just know there's somebody watching.
We've been aware of those conveyor belts in the ocean, those liquid flows for a long time. And if you look at a globe, look at England, where London is, and it's about the same latitude as Alaska. And yet England is much warmer than Alaska. Well, it's because all that warm water from the Caribbean is floating over to England and being released there. So that's what keeps England moderately warm.
Yeah,
I've heard the same. My understanding is that's kind of how Juneau, Alaska is. Like Juneau, Alaska is in the southern part of Alaska, and it kind of comes down a little bit into Canada on the edge, but the warm ocean currents make it that it's not all that, not as cold as we would think it would be.
Right, more temperate.
I'm not around. Have you found? I'm always on you.